Now, when you talk about gases, you must talk about the pressure. And pressure is something we haven't talked about before. But from physics, pressure is basically the force exerted on a given area. All right. And there's a lot more to pressure than we'll talk about, but we'll talk about pressure as it relates to gases. Now, what's interesting about pressure is that it was first explored by Torricelli and other Italian scientists in 1643. So that's quite a while ago. And Torricelli was the person who's given credit for developing the barometer. And the barometer is a measure of the pressure of a gas. Now, it was usually for atmospheric pressure, but you can use a barometer for all different kinds of things. Now, in a classic barometer, which is shown there on the right, you have a pool of mercury on the bottom and a tube with a vacuum in it on the top. And the pressure of the air forces the mercury up the column. Now, eventually, gravity starts to pull the mercury back down. So there's a place where the gravity overpowers the atmospheric pressure. But as the pressure goes up and down, that empty space in the top goes up and down, and you can literally read the length that the mercury goes up the column. And so if you are at 1 atmosphere of pressure, the length of the column will be 760 millimeters of mercury, which you can measure with just a ruler or something like that. Barometers have to be calibrated for the pool width and depth and the mercury density and lots of other things. And you don't have to use mercury, but it's a lot easier because of the density. We'll maybe talk about that in class more. But anyway, this is a barometer, and they have now, of course, electronic versions, but the classic mercury barometer is still seen as the gold standard for determining the gas pressure at any given moment. If you're measuring a barometer, the classic way is to measure from the depth of the mercury pool to the top of where the mercury column stops. And if you're at a standard atmosphere, which is like normal atmosphere, that's equal to 760 millimeters of mercury. And that's a conversion we'll use a lot. 760 millimeters of mercury equals an atmosphere. Now, as you know, there are 10 millimeters in a centimeter, so sometimes you see these listed as centimeters. That would be 76 centimeters of mercury for an atmosphere. A torr is a unit that's basically an homage to Torricelli, and a torr is the same as a millimeter of mercury. So if you have a standard atmosphere, that would be 760 torr. So a torr and a millimeter of mercury, same thing. There's another unit called a millibar that we will use once in a while. 1,013 millibars equals 1 atmosphere. We'll use this in lab. Some of our devices use millibars, so make sure you make a note of that. On the other hand, sometimes if you're watching news, they'll talk about so many inches of mercury when you're talking about weather. 29.9 inches of mercury is equal to 1 atmosphere. And again, we won't use that here in this class, but if you're watching the news, they'll talk about differences in barometer pressures, and they're always right around 29.9 or so inches of mercury. Now, mercury isn't the best element to use because it is kind of toxic, so you can use water. However, the density of mercury is about 13.6 grams per centimeter cubed. If you wanted to use, for example, water, which is 1 gram per centimeter cubed, the tube will be a lot higher. So you need to have about 34 feet of water to measure if you're going to measure an atmosphere. And having a tube that's 34 feet tall is not very useful when you're in the laboratory. Now, it is more accurate. You can definitely measure very small, minute changes to atmosphere, but you have to have like a multi-story level where you can put this water-based barometer out. And I saw one at a school I was at one time. It was fantastic, but again, you have to have very special kind of conditions. Now, the SI unit for pressure is called the Pascal, and 1 atmosphere is 101.325 kilopascals. A millibar is equal to 1 hecapascal, which is another metric unit. We won't use the Pascal too much, but in physics you might. So if you take physics and you want to relate all the things we're talking about, just FYI. The ones we're going to use a lot in this class are 1 standard atmosphere equals 760 millimeters of mercury, or 760 torr, same thing. We'll also use that 1 standard atmosphere is equal to 1,013 millibars. So those are the ones that we'll use in this class more than the others. Here's a question you might see. It says nitrogen gas has a pressure of 452 millimeters of mercury. What is the pressure in atmospheres? So what you would do here is 760 millimeters of mercury equals an atmosphere. That's a conversion factor. So you would take 452 millimeters of mercury. You would divide by 760 millimeters of mercury per atmosphere. The millimeters of mercury cancel out. You're left with atmospheres. 0.595 atmospheres is the answer you'll get. Atmospheric pressure is supposedly the pressure that you would experience if you're right at sea level. So if you go to Seaside, Lincoln City, Newport, one of those kind of places here on the Oregon coast, you should experience a pressure of about 1.0 atmospheres. However, as you get higher in elevation, then you start to have lower pressures. So for example, if you go to Timberline on Mount Hood, which is about 6,000 feet, you would experience a pressure which was less than 1 atmosphere. And even here in Gresham, Oregon, where the elevation is supposedly about 300 feet, you will experience less than 1 atmosphere. However, this does not take into account storms. Storms will make the pressure go up and down, and it's kind of fun to monitor the pressure as you go through. So people talk about the mile-high city Denver. You can see in that picture, the pressure is about 0.83 atmospheres. On the other hand, in Bolivia there, which is much higher, 0.62 atmospheres, and the top of Mount Everest, 0.35 atmospheres. If you've ever watched the movies of people climbing Mount Everest, a lot of times they have oxygen masks because the oxygen level is so low, they can't get the oxygen to climb. So they have these special kind of portable oxygen containers to keep themselves going, which is just fantastic.